Welcome to Brain Vision.
In this problem, we're going to talk about the work energy theorem. So basically, this theorem tells us that the work done by a particle or on an object that is equal to F times the distance along which the force was exerted is equal to the variation in the energy of that object. And what we have in our problem is you have to suppose that you are a member of a rescue team and you want to send supplies to a stranded skier that is located at a vertical height h at a slope with an inclination angle of inclination alpha, and you want to reach him and are going to find what is the speed with which you must send these supplies so that they reach the skier, given that the friction coefficient between the slope and your box of supplies is equal to mu. Now notice that the final energy of the block is just the gravitational potential energy at this point here, because it must reach the skier with no speed, so um, there's no angular I'm sorry, there's no kinetic energy. So F is just the final potential energy, and that is equal to the mass of the object times g times h, while the initial energy is equal to only the kinetic energy mv squared over 2. So the variation in energy is the final energy mgh minus mv squared over 2. Now the work done on the system is done by the friction force. And what we need to remember is that the forces acting on a block, are the gravitational force and the normal force. And given that the slope is alpha, then the normal force is equal to mg times cosine alpha. And also there is the friction force F. And the friction force is just the normal force times mu. So the work is N times mu. And notice that the friction force is pointing downward, so there's a minus here. I'm going to use it. So the work is minus N mu, and this is equal to delta E. Now, this is minus mg cosine alpha mu. Actually, there I should multiply it by d as well. I'm sorry. The work is the force multiplied by the distance d. This is equal to the variation in energy, and the variation in energy is just mgh minus mv squared over 2. Now d is this distance here, and notice that we can find d using that the sine of alpha is h over d. So d is h over the sine of alpha. Okay, so we have minus mg cosine alpha, I'm sorry, times h divided by sine alpha is equal to mgh minus mv squared over 2. The m's cancel out. So v squared over 2 is gh plus gh over times mu, I'm sorry, times mu over tangent of alpha. So v is equal to the square root of 2gh times 1 plus mu over tangent of alpha, which is the answer we were looking for.